Hello, 8th grade math students. Today we're going to be working with multiplication properties of exponents. Our I can statement for the day is I can determine the properties of integer exponents, including product of powers. So when we say product, we mean that we're multiplying. A product is the answer to a multiplication problem. Note, when multiplying powers with the same base for every non-zero a and integers m and n, when you have the quantity and it looks like a raised to the m power times a raised to the n power, all we're really going to do, if you look at this, is add the exponents together. Rewrite each expression using each base only once. So the base is going to be the number that we are raising to a power. So as you can see on example 1, the base is the same for both numbers. We have 3 raised to the 5th power times 3 raised to the 4th power. If I have 3 raised to the 5th power, that's going to look like 5 times, and then if I continue, I multiply 3 to the 4th, that's going to look like. So we can quickly see that really all we have to do is add the exponents together. And I do want you to show the work as far as how you came up with the answer. So in other words, 3 raised to the 5th power times 3 raised to the 4th power is really 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 raised to the 9th power. So you need to show this step and then your answer. Notice that the direction says rewrite each expression using the base only once. It does not tell us to simplify or evaluate. So remember again, the rule is taking the exponent and adding those together. The tendency might be to multiply because you are multiplying, so just make sure that you remember the rule. Going to number 2, now we have 5 raised to the negative 2nd power times 5 raised to the 2nd. So when the base is the same, which it is, in both cases it's a 5, then you can simply say 5 raised to the negative 2 plus 2. Negative 2 plus 2 gives us 5 to the 0 power, because a negative 2 and a positive 2 is 0. And we know that every number raised to the 0 power, the actual answer is 1. Let's think about this for a second and how that answer works out. What I just did is exactly what you would need to do to show your work, but let's talk about another reason to do that. If I have 5 raised to the negative 2nd power, we know that we should write that as 1 over 5 raised to the 2nd, because a negative exponent becomes a positive exponent in the denominator. So if I'm doing this 5 times 5 raised to the 2nd, then what I end up with is 1 over 25 times 25. I can put that over 1 if I'm more comfortable. And as you can see, if I showed my work that way, then that also, the answer is still going to be 1. Looking at number 3, now we have a decimal base. The decimal base is 45 hundredths. So all we have to do, 0.45 raised to the 3rd power, raised to the 3rd power, and raised to the 2nd power. So all we have to do then is add the exponents. 3 plus 3, of course, is 6. And then add 2 more. It gives us 45 hundredths raised to the 8th power. Simplify each expression. So once again, we're simplifying. In this problem, you can see that there is no value for the exponent. So in other words, we just want to simplify this. If we're talking about what we can add together, we want to look at the coefficients. The coefficient, of course, is the number in front of the variable. So I can go ahead and say 2 times 3, which is 6. And then I have n to the 5th plus n to the negative 2nd, so that's plus a negative 2, much better known as 5 minus 2. So simplified, I would have 6 n raised to the 3rd power. And that is your final answer. Another way you could get there Because on these problems, a lot of times there's more than one way to get there. We know that we want to do 2 times 3. That's a given. 2 times 3, those are the coefficients. So let me just rewrite it down here for you. And probably what I just showed you is the easiest way, but let's talk about another way. We would have, once again, 2 times 3, which is 6, and then n to the 5th. But then this n raised to the negative second power, remember that that means that I'm going to take the negative second, and well, it's always 1 in the numerator, and then it becomes a positive in the denominator. So if I multiplied across, I would get 6n to the 5th all over n to the second. Well, the n raised to the second is absorbed into the n to the 5th. Really, we're going to just subtract exponents. You'll learn that in a couple of lessons. So you'll have 6n to the 5th minus 2, or guess what? 6n to the 3rd. So again, that's just a different way to do the same problem. Number 2, we want to first tackle the exponents. I know that I'm multiplying each time. So I have 5 times 2, which is 10 times 3. So we have 10 times 3, or 30. Now I have the exponent x, so we want to pay attention. I see that there are 2 variables. There's an x and there's a y. So x, remember that any number, any variable that is raised to a power and I don't see it, it's always just going to be the number 1. That is really important to include because I know that if I'm doing x to the 1 here, or x to the 1st, and x to the 8th, that I'm going to add those exponents together. And then I can just bring down the y to the 4th. There is no other y power. So what do we have? 30 times x, 1 plus 8 is 9, and then y to the 4th. As far as the order that you should put your answer in, I've got an x and then a y, so we just try to put those in alphabetical order. That is the best way to present your answer. Again, simplifying, and if it helps, you might put a 1 in front of here, but really that just means 1 times 7. We always look at our coefficients first, so I know that anything times 1 is just going to be 7. So 1 times 7 in this case, because any number times 1 is always itself. So all we have as the coefficient is 7. I see we have the variable n, so I have n to the second, n to the 3rd, and don't forget that there is a 1 there as well. So we have 2 plus 3 plus 1, which is equal to 7 times n. 2 plus 3 is 5, plus 1 more makes 6. Final answer. Number 4. Tackle the coefficients. It looks like we have basically the same thing here with m to the second. I'm sorry, we have m's and n's. As far as the coefficient, we have 1, 1, and 7, still 7. And then the m's are going to be m to the second. Remember, this m has a 1 as an exponent. So we're going to put that there so we don't forget to add. And then n raised to the negative second power. So to simplify, we have 7 times m and then 3. Now we have a little problem here with the n raised to the negative second power because I can't have a negative exponent. So if I can't have a negative exponent, then I need to rewrite that another way. So n raised to the negative second power is going to be times 1 over n to the second. A negative exponent just becomes a positive in the denominator, and we use 1 as the numerator. So when we multiply across, final answer, we end up with 7 times m to the 3rd power all over n to the 2nd power. So I just want to emphasize once again that you cannot have a negative exponent. If you have a negative exponent, then your answer is not simplified. So let's say that you got to this step and you would have ended up with 7 times m cubed and you left it as n raised to the negative second. Your final answer can never have a negative exponent. So that's where you're going to go into changing it to the fraction. All right, last page, complete each equation. So what we're going to do here, you guys, is to fill in the exponent that is missing. So I have 4 raised to the second times 4 raised to some power is equal to 4 raised to the 12th power. And once again, let's just remember what we talked about to begin with. So if I have a raised to the n times a raised to the m, all we're really doing is adding the exponents. So I'm going to have a raised to the n plus m, and then that's going to be equal to a raised to the n m power. So what does that mean? Well, if I have a 2 here, then what has to be here in order to get the 12th power here? So then when we add n, I don't want to say a to the n m, I want to say a to the n plus m power, then 2 plus some number is equal to 12. That's going to end up being a raised to the 10th. So your final answer here would be 4 to the second times 4 to the 10th is equal to 4 raised to the 12th. So I just wanted to show you here in the process how you get there. You just think about what you add together to get 12. I want you to go ahead and pause the video and go ahead and do the next two. On number 2, you are filling in the box here, and on number 3, you are filling in, what are we filling in on number 3? You're doing the y and the x. So go ahead and pause the video, do those two, and then you can check your work. All right, welcome back. So we have all m's in this example, and we have m raised to the 11th power. So I see that I have 2 and 3. Well, together, 2 plus 3 makes 5. So the missing exponent would be a 6, because m raised to the 2 plus 3 plus 6 gives me m raised to the 11th. On the last example, we end up with y raised to the second power. So the only way to get to y raised to the second power then is to raise this y to the second power. Did you get that? I hope so. Okay, so we have y raised to the second, but then we have x to the third times x raised to something, but I don't see any x's on the right side of the equation, or as far as the answer is concerned, then that must mean that 3 had to cancel out. So the only way to get there is to use a -3. How does that work? If I was simplifying, I'd say x raised to the third minus 3, and then times y raised to the second. All that's left is y to the second, because that would cancel out. X raised to the 0 power, remember we said anything raised to the 0 power is just 1. So if it was 1 times y to the second, then that's going to give me y to the second. I hope that you learned something today about multiplying products or multiplying variables with exponents.